Welcome to the session 5 of Web Application Security. My name is Mahesh, and then in this session, I'm going to discuss about side effect of CRLF injection attack. So in the past, this is session 5. In the previous sessions, I have discussed about what is WASP, top 10 list, and then some of the security terminologies we use in this web application in understanding web application security. Then we have discussed about what is code injection, that is session 3, and session 4 we have discussed about CRLF injection. So as a side effect of CRL injection, there are different side effects of CRLF injections, and in this session I'm going to discuss about cache poisoning, right? Yeah, let's proceed. So what is a cache basically, right? So if you see this diagram, so in this context, I'm not talking about a cache that is used in software development. In this context, I'm discussing about a cache, HTTP cache or web cache that I'm going to discuss. So let us say you have a client which makes a request, and then the request is fulfilled by the server, and the server response is sent to client again, which client uses to show some content on the browser, or he uses for whatever purpose he requested. Now in this particular case, this is a single client sending one request, right? Or maybe multiple requests. But what if there are millions of requests, right? Or millions of clients? Now the load on the server goes up crazy. Now just to handle that, it was felt beneficial to introduce caches. Now that's how the concept of cache came into picture in case of web cache. And web cache is something. So now just let us rewind back. Instead of the request going to server, the request goes to cache, and now cache checks what are the signatures of the request, and the signatures of the incoming request matches to the signature it has stored. Then it responds to that request on its own, and then that's how we can reduce the load on the server. uh, so just to summarize, cache is a temporary storage area where it can store some content for a set duration, or based on, or for identified duration based on a set of rules, right? And it is used for speeding up the request responses, and it is going to help speed up network traffic. It is going to help reduce network bandwidth and congestion. Okay, let us proceed further. So what is so I just gave a high picture of what is a web cache. Right now there are few terms that we need to understand, relate, and these terms are relevant to a web cache. This could be relevant to any other cache types also, but in relevance to web cache, I'm going to discuss here. So there are three main terms. One is freshness, one is validation, third is invalidation. So freshness talks about how fresh the content that is available in the cache, or how fresh the cached content is. Now, in case of HTTP, there are two headers that are being used. One says expires, other is cache control max age. So these headers will basically tell how soon. So expire says how soon the content can become stale, right? And cache control max age says that okay, it is amount of time left for the content to become stale, right? So these two headers are basically indicators of freshness of the content. So similarly, if modified since and last modified headers are used to check the validation of the content. So yes, cache has some content, but is it really valid, right? So these headers will basically tell whether the content in the cache is valid. The third case is invalidation. Invalidation is a way where the content from the cache is deleted. So this content that we are deleting, maybe the content that has served its purpose, or maybe the content that is no longer being used. Maybe server overrides, the server feels that okay, there is some change on the server side for the response that it has cached, then server overrides it. Or it is possible that because in a cache we have limited size, and because of which when new request comes, the requests that are least served are replaced with the new request responses. So that is where this cache invalidation comes into picture. So adding some more details. So where and all web cache can be present, right? So if you see today's browsers, most of the browsers have HTTP cache in picture. So this is to reduce the amount of load on the end server, right? Now where and all. So This picture explains about where and all cache can be present. So for example, the cache can be present on the web browsers. It can be present on the network edges. So as long as it is within the corporate network, so this is a client side caching. Once it is outside, it could be server side caching. Now server side caching is possible. Caching is possible at internet service providers network and different places. Again, how this caching is located or the placement of the caching is decided. That is purely based on how frequently we are accessing some particular content, and how whether the content or request responses are very huge. So if so in this particular case, the client is just making one request which goes to server and then comes back, right? Now if the response or the request is very very huge, or both are very huge, then every node that it travels till the web server has to handle the traffic. So that's how it puts a lot of pressure on the network. To reduce that, it is possible that if you have cached large request responses, it is possible that it may not reach server, and then you get served at a early stages by some caches, right? Yeah. So that's a picture of where and all it can be possible, and how it helps fulfill the purpose. Now, what are the advantages and disadvantages? Now, as I said, already discussed, so cache helps in fulfilling frequently accessed pages very fast, right? So you try to access. Now, in normal case, what happens without a cache, request goes to server. But if there are millions of requests pushing on server, then server has to fulfill every request, which puts lot of pressure, bandwidth pressure on the server, and that's how server may slow down. So instead of getting a response after some duration, you get response faster if there is a cache. And some of the applications, right, so they are time sensitive. If you are not getting response within say 10 seconds, the server, the request it might try, the client might try to request again, or it may drop the request. So again, so in all such cases, cache helps serve the pages faster, and this is useful when you are trying to access some content very frequently. Now client requests need not reach the server always in this case, right? So that is one advantage. It reduces the load on the server. The third thing is, say suppose server is down for some reason, there is an outage, maybe server is taken for maintenance or server is crashed. Now in such cases, if there is a cache, it continues to serve all the requests that are coming from the client, and that's how clients are not blocked. And once the server comes up, again, server and cache can talk to each other and then refresh their pages. But in the event server outage happens, cache helps to ensure that clients are not blocked. And again, as I said, it reduces the bandwidth cost, network congestion, etc. So what are the disadvantages? It is because, see, this content is stored on the cache, and if for some reason server goes down, or server fails to refresh the content on changed content on the client, this proxy, then it is possible that all the clients that are accessing this content from the proxy may get a stale data. Right now, distributed caching is another requirement. Say suppose if there is a single node cache, it may become a bottleneck, because instead of this millions of requests hitting the server, they are now hitting the cache. If there is a single cache, then it is possible that it may become a bottleneck. Now in that case, distributed caching may be required. So if you have heard of CDN and other edge networks, they are kind of cache networks where they help serve the purpose of fulfilling the request faster by caching. Okay, so continuing, what is cache poisoning? So far we have discussed about what is cache, what are its advantages, where it is possible to locate these caches, and now let us discuss about what is cache poisoning. In the previous session, that is session 4, I had discussed about CRLF attack. CRLF stands for carriage return and line feed attack. Now this is basically introducing CRLF ASCII characters in the request responses by an attacker, where it puts a confusion to the server, like where exactly in the request response the server status line, the request response status line ends, or header start, header ends, body starts, body ends. So attacker might introduce some additional headers. He might add some malicious code which can act as a worm or anything, right? So given that, so see, if CRLF attack introduces some of the malicious code, and if this code is, or this malicious code or content is cached, whether it is cached in client's browsers or proxy caches, or uh, cache at the server end or at the client end. Now, and if these caches are serving a lot of customers, now all these customers becomes a target of this malicious content attack or CRLF attack. So that way, the attack gets spread very fast. So as I said, in this case of in such an attack, the wrong content is sitting in the cache, and this content is used by everybody who requests. So that's how an attack could be possible. So if attack vector or the content that is sitting on the cache is a worm, or some maybe spider or some dangerous code, then it gets spread to every other client that is using this content, right? So how this what happens in this kind of attack? Now there are two headers called pragma header or cache control header. Using this, if you set this pragma header or cache control header to no cache, so what happens is any such request comes for that particular request, the request is never cached. So what attacker does is he tries to clear all the existing pages by setting no cache for such a request. So he sends a request, he ensures that the pages are cleared. Now the next thing that he does is he sets last modified header or e tag. This is a feature of HTTP basically, headers. So using this header, he can set a future date where a malicious content can sit in the cache for a longer duration, right? So e tag is basically, I'll discuss in upcoming sessions. Basically it's a header which helps in reducing the network congestion and bandwidth by only caching certain content, or by replying with certain content, right? So it's a relative caching, we can say. So let us just quickly see some of the headers. So courtesy of this images, Google Images, I got this images from Google. Thanks to everybody who posted this, right? So if you see here, cache control says no store, no cache, must revalidate. So it means that you are not going to store it. So if you see pragma, there is no cache. Such a request is not cached. So that means cache is going to clean. If there is a request previously, it will go clean them. So similarly, there is something called max age. So it means that it is in seconds. So it says for next 30 seconds, this request or this response is valid, right? So that's the indication of I would say how fresh or how valid the data could be. So similarly, I had discussed about if modified since or if none match. So if modified since is or last modified, if you see here, right? So they basically tell, okay, when was it last modified, right? So come you making use of these different headers, uh, cache and the client decide whether the data is valid, stale, and if it is stale, the request goes to server, right? So how can this cache poisoning be prevented? So because cache poisoning is an outcome of possible outcome of CRLF attack. Now, if we can stop CRLF attack, then cache poisoning is possible to stop. Now, how CRLF attack can be stopped, that I had discussed in the previous session, but I'm for the sake of completion, I'll discuss it here. So any user fed input, if that sits in the response HTTP response headers without being validated, then it could cause a CRLF attack, right? The second thing, now when a request comes to cache checks the signatures of the request, and cache has a repository of this request. So it makes a match with the incoming request and its own request. So if both match, then it sends the response. Now um, if an attacker adds additional headers which is not present in the cache, now cache can reject such request and it can send the request to the server. So that way cache poisoning is not possibly going to happen. But what happens because of to reduce the load on to save some bandwidth or something, out of say request has 5 headers for example, and if uh, the replica or the copy of the request that is sitting on the cache, which it uses to map or to match the incoming request, is also making is also having validation for all the incoming headers. Then it is good. If it is not, if it is having only, say, incoming request has 5 headers and uh, cache takes care of only 2, then it is possible that cache responds for something that is not, I mean, cache is still responding because it is validating only 2 headers. Rest of the headers it is not validating. That can even cause this kind of attacks. But if there are more and more headers, having validation slows down the performance of the cache. So that's where what happens is it's a, yeah, it's a balanced game. And then yeah, but it is safer to have validation for every incoming header, right? So uh, for this session I used a couple of references. Feel free to go through these references, and I hope I gave some context on what is cache poisoning. And if you have any feedback, suggestions, and comments, feel free to add the same thing. And please subscribe to this channel. Thank you very much, and good day.